Good morning, AP Calculus from CCTI. Mr. Pashar here once again. Hope your day's off to a good start on this Tuesday, Cinco de Mayo, and also Teacher Appreciation Day. So I hope you appreciate Mr. Pashar. All joking aside, I hope you're having a good day. It is really Teacher Appreciation Day anyway, though. Anyway, there were some questions on differential equations, so I'm going to do two examples with you. The first one is number 4 from your worksheet, which is due today. Some of you had said that this is not separable, but I beg to differ. You have to kind of do a double switch, as I call it, in this problem. So we'll work our way through this one, and then I'm going to do number 8 with you, which is a little bit of a difficult differential equation to solve because we have the initial condition thing in there as well. So here's what we got here. We have dy dx of 5 minus 2x squared equals 3xy. So again, the classic technique is to keep dy on one side and get the dx differential over on the other side. So let's start off by doing that. So we're going to say dy of 5 minus 2x squared equals 3xy dx. Okay, so that's where we want to start off. Now this is where it gets a little bit more interesting, is essentially two things happen simultaneously here. If you do it one step at a time, I think it confuses you because it looks a little bulky. But think about in your mind what you want to do here. You want to get the x is over on this side because that's where your differential is, and you want to get the y's over here because that's what the differential is here. But the problem is the dy's got the x's and the dx got a mix of both x and y. So what we want to do mentally is think about dividing the y over to this side and dividing the 5 minus 2x squared over to this side. So what that double swap or double switch it gives us as a net is dy over y equals 3 dx over 5 minus 2x squared dx. So that's essentially what happens. It's like a double switch. Okay? Alright, so that's what we did. And then what I'm going to do is, I never like when it's written this way, even though the textbook likes to write like that. I'm going to call that 1 over y dy, and this is the 3x over 5 minus 2x squared dx. So now we're in great shape. So I beg to differ, it is separable, I did it right here. So go ahead and integrate both sides. Now this side is the usual character, the ln. So this is going to be ln of the absolute value of y equals, now this is the integral of 3x over 5 minus 2x squared dx. This is going to require u substitution, so let's go off to the side and think about it. So this is pretty standard at this point, I would think. So we're going to say let u be the denominator, 5 minus 2x squared, because when we power this down by derivative, that's going to knock out the x's. So u is 5 minus 2x squared. That means du, the derivative, is going to be negative 4x dx, which could be rewritten as du over negative 4x is dx. Don't you just hate when that happens? I know I do. Okay, so we've got du over negative 4x is dx. So that means now, when we go ahead and integrate, we're going to go ahead and have negative 1/4 times the integral of 3x over u du over x. So what I did was I put the 4 on the outside instead of leaving it here because it's a constant. That's going to get shoved out. Just like the x's go away there, and that 3 comes out, so we have negative 3/4 times the integral of 1 over u du. So now this is negative 3/4 times the ln of u plus c. So that means you've got negative 3/4 the ln, and our u is 5 minus 2x squared plus c. So that integral yields negative 3/4 the ln of 5 minus 2x squared plus c. And notice I dropped the bars. Okay, I dropped the bars on the ln because this thing is not going to become 0. It's going to be positive, so we don't need the absolute value bars. Is it wrong if you put the bars in there? Not really. I mean, convention-wise, someone with a PhD might give you a little bit of a hassle. But at the high school level, I think we could look past it. But for good practice, I put the parentheses in. So I'll go ahead and write that over here. Negative 3/4 the ln of 5 minus 2x squared plus c. Okay? All right, so we got that. And now let's see, what do we want to do? Well, we got to solve it for y. So let's go ahead and try to do that. So you know what tactic this is? Why don't I just write this up here? So we got the ln of the absolute value of y equals negative 3/4 the ln 5 minus 2x squared plus c. What we're going to do is we're going to raise both sides by e. Because e has that nice property, e to the ln of crap equals crap, right? So this is going to be e to the ln of the absolute value of y equals e to the negative 3/4 times the ln of 5 minus 2x squared plus the constant c. So this is nice because e to the ln of absolute value of y is just absolute value of y. So we got absolute value of y equals e to the negative 3/4 times the ln of 5 minus 2x squared plus c, right? And then how do we get rid of the absolute value of y? By putting a plus minus over on the right side. So y equals plus or minus e raised to the negative 3/4 times the ln of 5 minus 2x squared plus c. And now we got it. So this is a very nice and separable first order differential equation. Okay? So probably the biggest trouble, I would guess, is actually the algebra part. The calc stuff isn't too bad. It's just up here, this idea. It always comes back to algebra, right? As I always say, calculus is usually 1 or 2 steps, the rest is algebra or trig. And it was just that double swap that was probably giving a little bit of trouble. So why don't you pause here, see if you can go back and do this, and then I'll come back and I'm going to do problem number 8 on the worksheet, which is a little bit more difficult. Okay, we'll do that one next. Okay, so I hope you enjoyed that problem. Okay, so next is this problem here, problem number 8. So problem 8 says y times 1 plus x squared y times y prime minus x times 1 plus y squared equals 0. And we're given the initial condition that y of 0 is root 3. Y of 0 is root 3. Okay, so this looks kind of nasty. There's that one song from the 80s, I think it is a Janet Jackson maybe, Nasty, right? I think so. You guys might be a little bit too young for that, but nasty. So this is nasty. You have a lot of stuff going on here, multiplications. First step is, let's get rid of the y prime and call that dy dx. So we replace the y prime with dy dx to differential, so that helps us a little bit. And, you know, what is our next step? Well, we gotta start shuffling things around, right? We gotta start moving things around a little bit. So, of course, we try to usually get the dx on the other side. So that's what we're gonna do. So this is gonna be y times 1 plus x squared dy minus x times 1 plus y squared equals a dx. Technically it's a 0 dx, right? And now what I'm going to do is I'm going to try to manipulate this a little bit. As you can tell, we have a lot going on. We have y times a bunch of x stuff dy, and you got a minus x times a bunch of y stuff equals dx. Okay, so think about what you want to do here in your mind mentally on your next step here. Do you have an idea? Think you know what you want to do here in this one? We're going to take this guy and move it over to the right. So I got y times 1 plus x squared dy equals x times 1 plus y squared dx. So we move that, this is one whole unit, move it over. And now we're in a much better shape because we're starting to see how things are playing out. We're going to do a double swap once again, I think here. We want to get this guy over here and this guy over there. So as a net change, you're going to have y over 1 plus y squared dy equals x over 1 plus x squared dx. That's what you're going to get. Because remember, you're dividing, you're swapping both of those, right? Yeah, so that's good. The nice thing about this is when we integrate, they're identical. Only thing that differs is their letter. So if we integrate one, we actually get the other one for free. So why don't you take the time here and see if you can integrate either of these, and we'll come back and we'll slap our results down. Okay, so let's see what you arrived at. You should have arrived at the following, that this is 1/2 the ln of 1 plus y squared equals 1/2 the ln of 1 plus x squared plus c. So hopefully you did arrive at that conclusion. If you get one, like I said, you get the other one essentially for free, okay? Now, we have the initial condition. Y of 0 is √3. So this is your x, and this is your y. So we're going to go plug them in and solve for c. So we got 1/2 the ln of 1 plus √3 squared equals 1/2 the ln of 1 plus 0 squared plus c. Okay? So that's going to give you 1/2 the ln of 4, and this is going to give you 1/2 the ln of 1, which is 0. So that works out really nice over here. On the right hand side, you're just going to get a c. Now here's a little trick. We have 1/2 ln of 4. You could verify this in your calculator. We could write this as either 1/2 ln of 4, or we could go ahead and call this ln of 2. And I think it'd be easier to call this ln of 2. But check it out. 1/2 the ln of 4 is the same as saying ln 2. And that should make sense to you based on your log properties that you learned while we were still physically in school. Okay? So now we're going to go back and plug this information in. Okay, where we need to. So where are we going to go back to? We're going to go back to this step right here and plug that in. So now we're going to have 1/2 the ln of 1 plus y squared equals 1/2 the ln of 1 plus x squared plus the ln of 2. Okay? So we got 1/2 the ln of 1 plus y squared equals 1/2 the ln of 1 plus x squared plus ln 2. We'd like to get this in the end, if possible, to be y equals some kind of x. We may not be able to, and I think you'll see that that's going to be the case here. But we want to try to simplify this as much as we possibly could. So what I would do to start off here is I would multiply both sides by 2 to get rid of this 1/2. So we'll call this the ln of 1 plus y squared equals the ln of 1 plus x squared plus 2 ln 2. If we multiply everything by 2, then that's going to give us down there on the 2 ln 2. Okay? So now you got to kind of think about, well, where do we go next? Right? Where do we go next? Well, think about some of your log properties that we have, right? And how we solve log equations specifically. There's a little bit of a trick we could use here to kind of finish this up. You see what we might be able to do? You might be able to transform possibly something here. We can maybe condense this as 1 ln, right? 1 log right here. So you would have the ln of this times this, right? And see, that would come back up here. If you look here, this would come back. You might not be able to see that. Let me. Okay, there we go. Now you can see it. This part here, if we write this as 1 log, watch what happens. So this side I'm keeping the same. This is the ln of 1 plus y squared. This would be the ln of, we got 1 plus x squared. And this is plus 2 ln 2. That means the 2 came from up here, so this is really times 4, right? You see that? And then we can get rid of the ln's essentially because there was that property for solving equations that said if you have the ln of something equals the ln of something, you just set the guts equal. So what we have here, essentially, guys, is the fact that we got 1 plus y squared equals 4 times 1 plus x squared. So we have that, and essentially, at this point, there's really not much more we could do. Now, some people may write this as the absolute values of these things, and that's fine. Otherwise, you could just leave it without the bars because they're going to remain positive. So it's your call on how you want to handle that. Let me see how the book has it written. They kept the bars intact, but you could write it this way, or I would accept it without the bars as well too. But this problem was a little more nasty for the fact that you had a little bit of algebra to do, and you had to work in your log properties to help clean it up. So I hope this example has helped you guys to finish up the rest of your homework. And remember, AP exam is on the 15th. I sent you some materials on velocity. Please make sure you go and do it. You should have no problem learning that part because you know how to do derivatives. You're experts at that. Okay? So until next time, please stay safe. Enjoy the day that you're in. I know it's hard to sometimes, but we gotta try, and hopefully we'll get to see everybody sooner than later.